Let's start with this example where we have this class rectangle right here with two instance variables, length and width, a constructor that uses parameters to set them, an area method that returns the length times width, and a display method that displays the length and the width with an x in between. So, what would this output? Let's see. So first we have a rectangle that's 5 by 7, another rectangle which is set to R1, so therefore it's also a 5 by 7 rectangle, another rectangle which is also a 5 by 7 rectangle. So when we initially display them, the output is going to be 5.0 by 7.0, because remember that even though I passed in ints, the parameters are doubles and the variables are doubles, so therefore overall when I print it, it's going to be doubles. So 5.0 by 7.0 in one line, the next line 5.0 by 7.0, following line 5.0 by 7.0. And then we set r1.length equal to 4. Then we do the same display. Now what would happen? Well, it turns out it's going to be 4.0 by 7.0, well, because we changed the length of R1 to 4, and then 4.0 by 7.0, and then 5.0 by 7.0. So why is R2 affected along with R1, but R3 is not? And the reason is that basically when we define a rectangle, we have R1 points to this rectangle, let's just say we have that, okay? It's a poor representation, but that's how much we can do on a screen. Then R2, when we set R2 to equal R1, then R2 points to the same 5 by 7 rectangle. Just like in arrays, where when we did one array equals another array, that's how it worked as well. So basically in general, the equal sign is a very tricky thing to deal with. Basically, whenever you set one thing equal to another, you're basically making the variable point to the other thing. So R2 equals R1 means that R2 is the same thing as R1. And actually, a good indication is that when there is no new keyword, then there is no new object. So rectangle R1, that's a new keyword, so we generate a 5 by 7 rectangle. R2 equals R1, there is no new, so therefore there is no new object. So R2 points to this 5 by 7 rectangle. R3, however, so the initialization of R3 uses the new keyword, so it calls it the constructor again. It's a new object. So therefore R3 points to another 5 by 7 rectangle. So therefore, when I modify R1 to be a 4 by 7 rectangle, then R2 is now also a 4 by 7 rectangle because R2 is R1, it's the same thing. But R3 is not the same thing as R1. It just had the same value. So therefore, R3 does not get changed along with R1, so it remains as a 5 by 7 rectangle. Now, let's say we have R2 set to basically new rectangle 2, 3. So now, I did the equal sign. And what that means is since I did R2 equals, I'm redirecting R2. So I'm not modifying R1 because I'm not doing R2.length or something like that. I'm literally changing R2. So I'm not redirecting the object itself, I'm redirecting the variable. So therefore, now R2 points to another rectangle, a 2 by 3 rectangle. technically all of these have point zeros. So then now when I do r2.length equals 4, it doesn't affect any of the other rectangles. So therefore when I display it, it's going to be 4 by 7, 4 by 3, 5 by 7. And now I set R2 to be R3. So what does that do? R2 is now being redirected to R3. So R2 is now something like this. Or if you want a better view, you can have something like that. R2 is being redirected to R3. So now all of a sudden R2 and R3 are the same object. So when I do R2 dot length equals 6, notice I'm not doing R2 equals, I'm doing R2 dot length equals. Then in that case, now this thing is 6.0. So when I display it now, it's going to be 4.0 by 7.0, 6.0 by 7.0, and 6.0 by 7.0. And the results are shown below. First this, then that. Now here's another example. So we have this scale up method right here that appears to multiply the length by 2 and the width by 2. And then we create a rectangle, display it, scale it up, and then display it again. So what would the output here be? Well, obviously the first display would be 4.0 by 8.0. That's no surprise. But the second one, what would it be? Would it be 8.0 by 16.0 because it scaled up? Well, actually, no. It'll still stay as 4.0 by 8.0. And why is that? Well, let's work with the diagram again. So first, R4 is pointed to a 4 by 8 rectangle. And then R4.display, that's 4 by 8. Scale up of R4. So now, what does that actually do? So actually, remember how parameters work? When I pass R4 in, it's equivalent over here to saying rectangle R equals R4. All I'm doing is making a variable that points to the same rectangle as R4. Now, why does this R equals a new rectangle with double the length and double the width not change anything? The reason is because when we do this, we're doing R equals. So basically when I do R equals, I redirect this pointer thing. So now R equals, and then an 8 by 16 rectangle. And then therefore, when we're done with this method, actually it doesn't change R4. Now, how would I make it so that this scale up method actually modifies the R4 rectangle rather than do this? Well, in order to get it to actually modify the argument, we would have to do the following. R.length doubles, so times equals 2 or something equivalent to that, and R.width times equals 2. Or equivalently, R.length equals R.length times 2. So basically, if we have this, now we're not doing R equals. So initially, again, R is like that. However, we're doing R.length equals. We're not doing R equals. So therefore, R.length is this. So now we're changing R.length, not R, which is this. So therefore, now this thing is 8.0. Same thing with R.width. R.width times equals 2 just means now this thing is 16.0. And now, when I display, it's going to be 4.0, 8.0 for the first one, and 8.0, 16.0 for the second one, as shown below. And of course, if you recall, after this method is finished executing, R disappears. It no longer exists because we defined it in the scale up method, so therefore it disappears after the scale up method. Now, what about this example? Let's just say instead now of just singular rectangles, we have rectangle arrays. Now let's just say we have this array. So now, let's say we have another array like that. And now let's just say we had a display method for these arrays. So public static void display all for rectangle array. Such that for every rectangle I display it, so r.display. But anyway, now initially we have, let's say, display all rect arr and display all rect arr2. So at first we have the normal copy of the array. Now, here we have 3 levels of deepness. 1, what if we do rect arr2 equals, say, another rectangle array of, say, just a rectangle array of length 3 that contains just a bunch of nulls. Now, would that affect the display all of rect arr? Actually, no, because again, remember, even though rect arr points to the same array as rect arr2, they're not exactly the same thing. They point to the same array. However, when I do rect arr2 equals, I'm redirecting the pointer, not changing the array itself. So as a diagram, I could say, like, let's just say I have rect arr pointed to this array. I'm calling these RR0, RR1, RR2, and individually each of these point to their own rectangle. So RR0 points to, say, a 3 by 5 rectangle. RR1 points to a 4 by 7. RR2 points to a 5 by 9. Something like that. And now I have rect arr2 like that. So when I make rect arr2 equals a new rectangle array, I'm literally just ditching this. So now that goes to here. So basically some null objects. As you see when I display the other one, it's gonna fail. And basically the reason is because I tried to access a method of some object that really doesn't exist. We'll go over that later, but for now just know that rect arr did not change. Now, here comes the second level of deepness. So slightly deeper than this. So this modification literally does nothing except change this rect arr2 array. So now, rect arr2 of 0 equals new rectangle 611. So again, going back to our previous diagram, this is what it looked like before the change. And now, what does it look like after the change? Well, basically, rectarr2 of 0 equals new rectangle 6 comma 11. So I'm doing this thing, which is rr0 in our diagram right here, equals. So therefore I'm changing this pointer, this arrow. So let's change that quickly. So now I just redirected this thing to a 6 by 11 rectangle. And now notice that rectarr is also modified right here. And rectarr2 is also modified. The arrays themselves are modified. As you see when I try to display them, they're completely modified. The second one's modified, but the first one's also modified. Now, however, why is this only the second level of deepness? It's not deep enough. It doesn't change everything. Well, there's 3 by 5 rectangle still exists. So basically, if I were to say rectangle R5 for some particular reason equals this thing beforehand. So before all this change, so I would have something like the following. R5 points to this. So now I have this. So when I do rectarray 2 of 0 equals new rectangle 6 comma 11 now, what happens? Well, now rectarr2 is the same thing as rectarr basically. It points to the same array. So I'm accessing this array, and in particular I'm accessing element 0. So this element, rr0 in our diagram. Now I'm doing basically rr0 equals. So basically that changes this arrow again, as I showed earlier, like that. Now, notice something else though. R5 is not changed. So basically R5 still points to the 3 by 5. All that I did was redirect this RR0 to 6 by 11. So basically this element is changed, so as a result both of these arrays are changed. However, the rectangle the element was originally pointing to was not changed. All I did was redirect the element to another rectangle. And as more proof, if I just display, so r5.display, just display the rectangle R5, we see that it has not been modified. It's still a 3 by 5 rectangle. Even though both arrays have been modified, this variable has not been modified. Now, so here comes the third level of deepness. So the first level, this one only changes rectarr2, not even rectarr. This one changes both arrays, but not the rectangles themselves. The third level of deepness is rectarr2 of 0 dot length equals, say, 8. So now, let's go back to our original diagram again, where we had something like this. And now let's see what rectarr2 of 0 dot length equals 8 does. So rectarr2 of 0, so that's this element, and then dot length. So all of a sudden now we're dealing with this variable, the length variable. When we do the length variable equals 8, so now all of a sudden the length variable has changed. So the rectangle itself has changed. Now we notice that the impact is widespread. Basically, it impacts both arrays. It impacts the element itself, which means it impacts what the element points to. It impacts the rectangle itself, and the length variable in particular, because that's what I did. Dot length equals 8. So this thing is changed. As a side effect, R5 is also changed. So now as you see, when I display everything, it's 8 by 5. So the first array, it's changed. The second array, it's also changed. And the rectangle R5 is also changed because of this. Because I accessed an internal variable. So this thing changes the rectangle itself, basically the length variable, which changes the rectangle itself, and automatically also affects both arrays, because both arrays point to that element, which points to the rectangle, and the rectangle itself is modified. So these are the 3 levels of the deepness for arrays of objects so far. So basically, in general, if you modify an internal variable of a thing, then the changes are long lasting. However, if you just modify the thing itself using an equal sign directly, it's not actually going to modify the thing. So rectarr2 equals, all that would do is redirect this arrow. Rectarr2 of 0 equals would redirect this arrow, which is a bit more long lasting because, well, rectarr also gets affected because the element itself, the arrow, gets affected, this arrow. However, if I directly access the length variable and set equals, then I'm changing this thing. So then therefore, it was originally 3, now it's 8. And even other rectangles that are pointing to that rectangle get modified. So then, therefore, say R5 gets modified. Here's another example. Let's say we have these 3 rectangles right here, and then we put them in an array, and then for every rectangle in the array, I seemingly change it to a 1 by 1 rectangle, and then display the array. However, when I run it, it appears that it doesn't work. And why is that? Well, let's turn to the diagram. So basically we have rectangles R6, R7, and R8. They're each pointed to an object. And then we have a rectangle array whose elements also point to the objects. And for convenience, I'm calling their elements RR0, RR1, and RR2. Note that the elements are not the exact same thing as the R6, R7, and R8. They just happen to point to the same object. So when I do something like R6 equals, that doesn't modify the array. Similarly, when I do rect array 3 of index 0 equals, so the element equals, that's not going to change R6. However, if I do modify the internal variables, it's going to work. So now what happens inside this enhanced for loop? Well, now for every rectangle R in RR3. So what does this do? So basically, the way for each loop works, R points to this rectangle right here initially. Basically, it loops through each rectangle. So initially it's here. Then I do R equals new rectangle 1, 1. So basically now we have, instead of this arrow, we have something like that. And then similarly, the next iteration of the loop, when R gets pointed to this rectangle, all R equals does is redirect it to another 1 by 1 rectangle. So say this 1 by 1 rectangle here. Note that these 1 by 1 rectangles are actually technically different. And then similarly, when R gets redirected to this rectangle, again, it gets pointed, when I do R equals, all it does is point to a new 1 by 1 rectangle. So basically, now again, R points to a 1 by 1 rectangle like that. Notice that these 1 by 1 rectangles are actually different because I have a new keyword. I'm generating a new object each time. It's not too relevant because they disappear after the loop. And then R disappears. And Java's garbage collector is going to find these, realize there's no way to access them because R disappeared, and just get rid of them. And then now, when I display all, it's going to show the original rectangles because nothing was actually changed. Now, how do I get this loop to actually change the rectangles? Here's how. Instead of R equals, I do R.length equals, which is, you have to modify a variable internally in order to actually modify the object. So you have to modify some variables of the object or something like that. Otherwise, it's just going to modify the pointer, which is probably not what you want. So R.length equals 1. R.width equals 1. So now it works. It's all 1.0 by 1.0. Why is that? Well, now R is still pointed like that. And now R.length equals 1. So we're doing R.length equals, notice. We're not doing R equals. If we did R equals, then we would do that. However, we did R.length equals. So that basically means we're changing this variable. So 1.0 there. R.width equals 1. And then R gets redirected. So now, say R is here. And that is 1.0. That is also 1.0 because R.length equals 1 and R.width equals 1. R gets redirected to, say, here. And then that's 1.0, R.length equals 1, R.width equals 1. Then afterward, basically, when we display all, it's going to display all ones. Because the rectangles themselves were modified, so the arrays are modified. And actually, so at the same time, R6, R7, and R8 were also modified. So R6.display, and it's also going to be 1.0 by 1.0 as shown below. Here's another example. What if I do R6, say, equals new rectangle 4.2, 8.7. Then what would happen? Actually, it turns out now if I do that, it's just going to change. Since I did R6 equals, it's just going to change the pointer. Because notice that R6 is not the same thing as the element of the array. It's just pointing to the same object. So if I redo the pointer, it loses all connections. So 4.2 by 8.7, like that. And now R6 is modified, but notice that the array is not modified. So if I do display all of rect ARR3, it's gonna display all ones. However, if I do R6.display, it's gonna show 4.2 by 8.7 because that's the only thing that this assignment changed. And another thing, if you really want to like use the constructor instead of just changing the variables, because sometimes that can get sloppy. So basically, if you really want something along this lines, but you actually want to modify the array, then unfortunately you cannot use one of these loops. You must do something like a normal for loop, looping through the indices. So for int I equals 0, I is less than rect ARR3.length, I plus plus, rect ARR3 of I equals a new rectangle, say 2.4, 3.5. And now all of a sudden, if I do display all of rect ARR3, it's going to change because I modified the elements themselves rather than some other random variable that points to the same object.